Question number 5 is on atomic and modern physics, and it will be dealing with photoelectric effect. We have a light of this frequency, which is incident on a metal surface, and the threshold frequency is this. By the way, threshold frequency of a particular material is a kind of property of it. It does not vary. Every material has their own threshold frequency. So this particular metal now has a threshold frequency of 8 times 10 raised to power 14 at. What is the maximum kinetic energy of the emitted photoelectrons? So what happens is that if you have a metal and then light is being shown on the surface of the metal. So you have light incident on the surface of the metal like this. This light is capable of emitting electron from the surface of the metal. But before it can actually do that, it must vibrate at a minimum amount of energy first. The electrons must begin to vibrate at a minimum amount of energy. This minimum amount of energy is called the work function. Is called the work function, and it is the product of the Planck constant and the threshold frequency. So this is just to get the electron ready for them to start moving. They are not moving yet. They're not being ejected from the surface of the metal. But here's the thing: once they attain that threshold frequency, once the electrons are vibrating at that frequency, any further increase in energy that you supply to the system will cause them to be ejected. And that implies that this remnant is what gives rise to their kinetic energy. So the further addition of energy into the system is what gives rise to their kinetic energy. So that implies that if you are supplying a form of energy into the system, let's call the energy supplied, let's call it ES. Then what will happen to this ES is that you are going to, first of all, this ES, if it's going to liberate electron from the surface of the metal, there is, first of all, it must cater for the work function first. So that means that it is the product of HF naught plus, if you now begin to emit electron from the surface of the metal, movement, the energy that the electron will possess is a kinetic energy. So this will now be plus the kinetic energy of the electron. So the energy that you supply must be able to do these two things. First of all, it must be able to make the electron vibrate with their work function, that is at the threshold frequency. Then after that is done, if you have supplied enough energy, then you begin to liberate electron, which will now possess kinetic energy. So now we are looking for the kinetic energy of this guy. So if the light that you are supplying has a frequency of this, so that means that the energy that the light is supplying is going to be H multiplied by the frequency of the light, and then it's going to be H multiplied by F naught plus kinetic energy. Since what we're looking for is the kinetic energy in this place of the emitted photoelectrons. So we have, this is going to be HF minus HF naught, which will be H multiplied by F minus F naught. And that will be our Planck constant is 6.6 times 10 to the negative 34 multiplied by the difference in this frequency. We have 1.2 times 10 to the 15 minus 8 times 10 to the 14th power. Now, to subtract stuff like this, you actually have to make them of the same power. This one is of power 15, this one is of power 14. So you need to make them the same before you can do anything here. So what you can do here is that if you increase the power of this one by 1, that implies that you're multiplying by 10. But that would go against the value that we're given. So that means that you have to divide this actual number itself by 10. So you have 0.8. Instead of this, you have 0.8 times 10 to the power of 15. So with that, now you have a perfect thing to work with. So 1.2 minus 0.8, I guess that should be 0.4. 1.2 minus 0.8, that's 0.4. So you have 0.4 times 10 to the power of 15, then multiply by 6, 0.4 multiplied by 6.6, that is 2.64. So we have 2.64. So now we have negative 34 plus 15, negative 34 plus 15, and that's negative 19. So that will be 2.64 times 10 to the negative 19 joules, times 10 to the negative 19 joules. So that will be the correct answer. So the correct answer is this guy right here. So that's basically how you solve problem like this. Don't forget to subscribe, like, and comment on this video. I'll see you in the next one.